the past few sections were all about factoring. Whether you were given a trinomial or maybe a binomial that was a difference of squares or a difference of cubes or a sum of cubes or maybe a four-term polynomial, we had all different methods that we could use to factor. This is where we can apply them because, and I guess this is kind of going back a little ways now, but when we had linear equations, like in the beginning of the course, we didn't really need anything extra. Like we didn't need all this factoring stuff. But now, what if you have an equation that instead of being linear, what if it's got a polynomial in it? So then we're going to have to do some extra stuff, and that's where the factoring comes in. So basically the two things that we need to solve polynomial equations are going to be that and this right here, this thing called the zero product property. So that comes in really, really handy. So basically what you end up doing is you get a zero on one side and you try to factor the other side to be able to get the zero product property to work. But the idea behind it is that if you have two quantities multiplied together and you're getting a product of zero, then one of those has got to be zero. Right? I mean, I guess you could look at it logically from the other perspective and say, well, if neither one was zero, then if you multiplied them together, you would have to get something non-zero. That's also true. But the thing to keep in mind is that this only works for zero. So there is a trap, which is trying to do this for values that aren't zero, but that doesn't work. So like I just threw an example in here. If a times b was 2, that doesn't mean that either a is 2 or b is 2. They can both be something else. Because you say, well, what if a is 1/2 and b is 4? You multiply those together, you get 2, and neither of them are 2 themselves. Same thing with if a is -10 and b is -1/5. You multiply those together, negative times a negative is a positive, and you're going to get a 2. So it only works for 0, but it comes in really, really handy. All right, so a quadratic equation, basically it's one that has a quadratic polynomial, which would be one of degree 2. So it's one that you could write in this form, and we're going to see a lot of things that look like that. Ax squared plus bx plus c equals 0. And if that's going to be a quadratic equation, it's got to have a degree 2 polynomial in it. So a can't be 0, right? Because you got to have the x squared term in there. But a, b, and c are real numbers, and just a can't be 0, so you have the correct degree. And a quadratic equation and a second degree equation are the same thing. Usually the term quadratic is used, but really that just means degree 2, right? Which would be that your largest exponent is a 2. And then solving quadratic equations, number 1 jumps right to the zero product property, where the thing that's on the left side is already factored. So usually you don't start off here. Usually you kind of end up here and then use the zero product property. But this would have been a polynomial of degree 2 before it got factored, right? But with number 1, the idea is, how does the zero product property work? Because we got a product on the left side, got 0 on the right side, but by the zero product property, it means one of the components of that product has got to be 0. So either 6x minus 7 equals 0, or x plus 1 equals 0, right? So there's the zero product property right there. So I guess I can kind of label that. I'll use a different color, right? So this step right here to go from there to there, that is the zero product property, right? That we can say that based on this product being equal to 0. But then we can just solve those individually, and they're not that bad, especially the one on the right, because you just subtract 1 from both sides and say, okay, well then x is equal to -1, right? So that would be one possible answer. This one over here is 2 steps. You have to add 7 to both sides, and you get that 6x equals 7. And then if you divide both sides by 6, you get that x is 7 over 6. So those are both going to be answers. So the way that our homework likes this written out is as a set. So the solution set would be 7/6 and -1. And there we go. And with the rest of them, you typically have to do the factoring first, but then it turns into this, where you end up using the zero product property. So in number 2, we got to factor that thing. But it's not too bad, because remember, the first thing to do when you're factoring a polynomial is to see if there's a common factor. And it looks like there is, because 2 and 12 are both even, and then the first term's got an x squared, the second one's got an x. Looks like we can factor an x out. So it looks like we could factor out a 2x, and then we'd be left with x minus 6, right? Since 2x times x would give you the 2x squared, and then 2x times 6 would give you the 12x. And then we've got a product here. I mean, really, this is three things multiplied together, because it's 2 times x minus 6. So you could jump right to saying that x equals 0 or x minus 6 equals 0, because the 2 certainly is not going to be equal to 0. But I think maybe it's easier to see this time just if I write it this way, where either 2x is 0 or x minus 6 equals 0. And then we can just solve those. But if 2x equals 0, that would force x to be 0. And I forgot the or. Since I got to write it small, I'll make it a different color. Or. Okay, and then the other one, I guess we have to just add 6 to both sides, so x would be equal to 6. And so then the solution set would be 0 and 6. Okay, I'm getting into more elaborate factoring. 3, we've got a trinomial on the left, so we're going to have to factor that thing first. So I guess what I can do is kind of section this off and say that that's what we're going to do. So maybe a different color would be good. All right, so let's say if we are factoring a squared plus 12a plus 35, and then if you're looking at this and going, well, because of the plus 35 on the end, they got to be the same sign, right? The two constants in your binomials, and then they both got to be positive because you got the positive middle term. Sure. What we're looking for is we need a pair of factors of 35 that sum to 12. And so it's going to be, I guess, the most conventional ones, right? 7 and 5. Right? When you think of things you multiply together to get 35, that's probably the first thing you think of. And they do add up to 12, so we're good. Right? We need those. And so that means that a squared plus 12a plus 35, if we're going to factor that, it would be a plus 7 times a plus 5. And then we're going to use this back on the left, because that's how the left side of this equation is going to factor. So we'd have a plus 7 times a plus 5 equals 0. But then we got a product on the left, so we can use the zero product property. So a plus 7 equals 0, or a plus 5 equals 0. So either a is negative 7 or a is negative 5. And so our solution set would be the set consisting of negative 7 and negative 5. Done. Okay. 4 is a trap, because when you look at 4, it looks like the left side is factored, which is true, right? The x is factored out. But then that's not a 0 on the right. So the thing that's the trap would be trying to use the zero product property without having a 0, like saying that x equals 30 or x minus 7 equals 30, but that doesn't have to be true, right? If you're multiplying two numbers together to get 30, they don't have to be 30 and 1, right? They could be 6 and 5. That works. So that property won't work when you don't have a 0 over there. So it's sort of a red herring, I guess, would be a good phrase for what's happening, where it looks like we've got it to where we don't have to do very much, but that's not really true. And it's actually helpful to multiply this back out. So if we do that, we'd have x squared minus 7x, and then we'll have a 30 over here. And we want to get a 0 on the right side, so if we just subtract 30 from both sides, that'll do it. And then we'll have x squared minus 7x minus 30 equals 0, and then we just have to see if we can factor this thing on the left. So let's see here. I guess go back to the brown. So factoring x squared minus 7x minus 30. So we're going to need a pair of factors of negative 30 that sum to negative 7. All right, so then it looks like then we would need negative 10 and 3, right? Multiply those together, you get negative 30. You add them together, you get negative 7. So, okay, we're going to need that. And so that would mean that x squared minus 7x minus 30 would be equal to x minus 10 times x plus 3. And then we can use this factorization on the left side of the thing that's in blue. And that's what we're going to do. Color didn't change. There we are. So, all right, over here, x minus 10 times x plus 3 equals 0. So using the zero product property, then either x minus 10 equals 0, or we'd have x plus 3 equals 0. So that means that either x equals 10 or x equals negative 3. And those are our answers. I'm kind of out of space to be writing the solution set notation, though. All right, so be careful with that, with things like number 4, where it looks factored, but you can't use the zero product property. Number 5, I think the most noticeable thing is we got a fraction in it. And I guess if you want to follow my strategy, I would get that out of there. I would prefer it if we had no fractions. And I think most people are on the same page with me there. I don't like to say everybody probably thinks that generally, but this is one where probably everybody thinks that, right? It would be better if this was all integers, but we can have that. We just have to clear that one fraction. So if we multiplied both sides by 8, that would do it, right? And we can do that, right? As long as you do the same thing to both sides, right? So we're going to multiply both sides by 8. So 8 times 3/8 x squared plus x minus 2 would be equal to 8 times 0. So the thing on the right is just 0, right? But then on the left, distributing the 8, we'd get 3x squared plus 8x minus 16. That's one where maybe this is a rainbow, and that was how I did it, actually. So let's do the rainbow. Perhaps different color since we're doing the rainbow. So factoring 3x squared plus 8x minus 16 and rainbow. So what we need is we need a pair of factors. I missed the T. Factors of, well, it would be a times c, which here is 3 times negative 16, which is negative 48. That add up to 8. Okay. So they've got to be different signs because of that negative 16, right? So we multiply them together, we got to get a negative. So they got to be negative, so different signs, one positive, one negative, but the positive has to have the bigger absolute value, I think. But maybe not. I guess we just have to kind of, well, yeah, because they add up to 8. So yeah, we just have to kind of try stuff here. So let's see. 8 and negative 6, that's not going to work. Right, because that adds up to 2. 12 and negative 4. Yeah, right, that adds up to 8. So then 3x squared plus 8x minus 16 we could rewrite as 3x squared plus 12x minus 4x minus 16. And then we can factor that by grouping. So we'll have 3x squared plus 12x in the first group, plus negative 4x minus 16, and factor a 3x out of that first group, and we'll be left with x plus 4. And then if we factor a -4 out of the second one, another x plus 4. And then we can factor the x plus 4s out of our two products, and we'll have x plus 4 times 3x minus 4. And there's the factorization that we can use on the left side. Okay, so I'm going to take that, I'm going to put it over here and say this works out to be x plus 4 times 3x minus 4. And we can use the zero product property, right? We got a product on the left and a zero on the right. So x plus 4 equals 0, or 3x minus 4 equals 0. We solve the one on the left, x just has to be -4. And if we solve the one on the right, we'd have that 3x equals 4, which would then mean that x is 4/3. And I think I've got enough room to get the solution set in here. So the solution set would be the set consisting of -4 and 4/3. That 3 doesn't look so great. Let me fix that up. There, now it looks like a 4/3. Okay, so a little more going on with that one. We had to clear the fraction first, but even on top of that, it was one that we had to factor where it's a trinomial where the leading coefficient wasn't 1, which led to the rainbow method over here. But once we got that, once we got the factorization, then we're good to go, right? Because we've got it written as a product, so then we got a product equals 0. Zero product property tumbles right out. Okay, next, number 6, I guess, is kind of like number 5, except that we have to move some stuff. Really, we just have to move one thing, right? We want a 0 on one side, not a 10r. Okay, it's not a hard fix. All right, we just have to do that. Subtract 10r from both sides, and we'll have 2r squared minus 21r plus 40 equals 0. This one, it's another trinomial on the left where we've got a leading coefficient that's not 1. So maybe this is another rainbow. So we can do it that way. So, and I guess if you see it right away, like if you can do it with the 2r and the r, and then just try in different pairs of factors of 40, then, I mean, I think you'd actually get there pretty quick here. But we'll do it with the rainbow method. So factoring 2r squared minus 21r plus 40, rainbow. So we're going to need a pair of factors of a times c, which here is 2 times 40, which is 80. That add up to -21. Okay, so what we know just from up here, and I think maybe I can write this in but make it real small. So just kind of off to the side, like the plus 40 at the end would mean they have to have the same sign. But then the minus 21r would mean that they're both negative. So, okay, then they both have to be negative. So for 80, if you think, let's see, like negative, I don't know, -20 with -4, that doesn't work. That adds up to -24. So it's close. They need to be a little bit closer together. But 80 is divisible by 5, right? It's -16 times -5. Yay. Right? That adds up to -21. So, all right. Then we've got the 2r squared minus 21r plus 40 is equal to 2r squared minus 16r minus 5r plus 40. So then we can group. So 2r squared minus 16r in the first group, plus the minus 5r plus 40 in the second group. Can factor out a 2r out of the first group, and we'd be left with r minus 8. Factor a -5 out of the second group, also left with r minus 8. So we're going to have r minus 8 times 2r minus 5 when we factor the r minus 8 out of those two products. Okay, now we got the thing that we need. So going back over here, on the left side, we know now that this factors into r minus 8 times 2r minus 5. And so that means that either r minus 8 equals 0 or 2r minus 5 equals 0. So here we'd get r equals 8. And then here, 2r equals 5. So then r is 5 halves. And those are our two answers. So yeah, number 6 and number 5, about the same, right? They both involved factoring a trinomial that had a leading coefficient that's not 1. And when that happens, a lot of times you do get one of the answers, or maybe both, being fractions. So like we got a fraction with the 5 halves. Before, you can still see it on the screen, we had a 4/3. They happen, right? Improper fractions, both, but that's okay. Number 7. Well, we don't have a 0 on one side, but I think you can tell what we're going to do. We got 4 terms, and it looks like we've got, if you go term by term, each degree from 3210 is showing up, and that's typically when you can factor by grouping. So I'm just going to subtract a 16n and a 48 from both sides to get a 0 on the right. Then on the left, we'd have n cubed plus 3n squared minus 16n minus 48. Okay, well then we can group that. So n cubed plus 3n squared plus negative 16n minus 48 equals 0. And then we can factor an n squared out of this first group, and we'll be left with n plus 3. And then in the second group, we could factor out a negative 16, and we'd be left with n plus 3. All right, so if we factor out the n plus 3 out of those two products, we're going to be left with n squared minus 16 as the other part. And we could use the zero product property here, but the thing that I would rather do is say, well, wait, this n squared minus 16, you could actually factor a little further, right? That's a difference of squares. So the n plus 3, like that's done, right? It's degree 1, you can't factor those any farther. But n squared minus 16, that factors as n plus 4 times n minus 4. So I'll use a different color to section this off, because I'm going to need to kind of move over a little. All right, and then back to blue. Okay, so now we have a product of 3 things equal to 0, but the zero product property extends to that. So it's okay to have 3 things multiplied together to get 0. It's still the case that one of them would have to be 0 for the product to be 0. So now you'd have that n plus 3 equals 0, or n plus 4 equals 0, or n minus 4 equals 0. And so then you'd say, well, then solving the first one, we could have negative 3. That would work. The second one would be negative 4. And then the third one would be 4. So the solution set here would have 3 things in it, right? 3 numbers. So negative 3, negative 4, 4. They all work. And one other thing that I think is worth mentioning is when you've got it set up where you've got the 0 on one side and the polynomial on the other, whatever the degree of the polynomial is, it's possible to have that many solutions. You could have less than that, right? Like if you had a perfect square trinomial, then you're probably just going to have 1, even though it's a degree 2 polynomial. But here, like if you just look, and I need a different color to point at this, but just like right there, where then you got a 0 on one side and then the polynomial on the left is degree 3. The number of solutions that you could have is up to and including 3. So you might have 3, you might have 2, you might have 1. I guess you could have, actually no, now with a cubic you couldn't have 0. But you could have 1, 2, or 3 potentially. But then, and yeah, here, like you could have 3, right? Because the degree is 3 and we ended up with 3. So that's okay when that happens. However, there is no guarantee that you will get that many. And this is some excellent foreshadowing by accident, because in number 8, that's degree 4, but we're not actually going to have 4. So let's see what we're going to do with number 8. I guess the first thing, well, there are 2 things that you probably notice right away. One is that we don't have a 0 on the right side, but we can get it pretty easily, right? You subtract 30 from both sides and we're there. The other thing is that we got a common factor. 6, 24, and 30 are all divisible by 6. We'll get the 0 on the right side first, then we'll worry about the common factor. So if you subtract 30 from both sides, then on the left, you're going to have 6x to the 4th plus 24x squared minus 30 equals 0. And yeah, now there is a common factor to deal with. If we factor out that 6, we'll be left with x to the 4th plus 4x squared minus 5 equals 0. You could divide both sides by 6 here to get rid of that 6, and some people view it that way, right? Because if you divide 0 by 6, you just get 0, and if you divide this left side by 6, then the 6's are going to cancel. The other way to look at it is you got a product here, right? 6 times this polynomial, and the product has to be equal to 0. So if we're going to use the 0 product property, the 6 can't be 0, so that means the polynomial would have to be. So you could also just go ahead and jump to saying that this polynomial has to be 0 by virtue of the 0 product property. But then we're going to have to factor this thing if we can do it. And the exponents are bigger than usual, but notice it's the same relationship that we usually have with a trinomial, right? Usually it's x squared and then an x to the 1st, but that's a situation where one of those powers is twice the other. And that's still what we've got, right? 4 is 2 times 2. All right, so we're going to have to factor that thing. And this is going to be one of the other techniques that we use once in a while. So factoring x to the 4th plus 4x squared minus 5. You could do it like using long division or synthetic division, just trying factors of -5 and seeing where you end up. That would work, but I think we'll get there a little faster with substitution, which we can use because we have one power that's twice the other power. So we could just say, let u be x squared, because then x to the 4th plus 4x squared minus 5 we could rewrite as u squared plus 4u minus 5. So I just have the u going direct in for that x squared that was multiplied by the 4, and then x squared squared is x to the 4th. So if I just sub in a u for x squared there, I get u squared. But then this thing factors, right? Because then to factor that, you would need a pair of factors of -5 that add up to 4. And you could say, well, then that's just u plus 5 times u minus 1. Right? There aren't a lot of pairs of factors of -5, right? I mean, it's either a -5 with a 1 or a 5 with a -1. And we had to get the plus 4, so it's got to be the 5 with the -1. But that's not really where we want to be. We want to back substitute. So back substitute, because this needs to be in terms of x. So we'd have x squared plus 5 times x squared minus 1. Okay, this is usable, right? So now, if I go back to blue, I'm going to put it over here on the left side. So we'd have x squared plus 5 times x squared minus 1. All right, and then these are degree 2. So the x squared plus 5, we can't really do anything with that, right? It's a sum, so there's nothing that we can do. But here, this is subtraction, and this is the difference of squares, right? X squared is a square, 1's a square. So we could actually factor that. So the x squared plus 5 is just going to stay here as an x squared plus 5. And that x looks really terrible. But then we could factor the x squared minus 1 as x plus 1 times x minus 1, and that's exactly what we're going to do. And again, we've got a product of three things equal to 0, so we could just do these individually. Let's say x squared plus 5 equals 0, and then x plus 1 equals 0, and then x minus 1 equals 0. The last two are easier, right? Because then here, the last one, you'd say, well, that means x equals 1. This one, the middle, means that x equals negative 1. What about on the left? On the left, actually, we're not going to get anywhere, because if you think about, like we just with the x squared, if you square 0, you get 0. If you square anything else, you get a positive. So this right here, like that expression on the left side, that can't be less than 5, which means you couldn't solve this, right? Because there's no way you could get it to be equal to 0 if it can't be less than 5. So the only solutions are positive and negative 1. So where I said at the very, very beginning that even though this was degree 4, right? I mean, like right here, that thing on the left side, it's a degree 4 polynomial. But that just means you could have up to 4 solutions. You don't have to have 4. You could have less than that. And here we ended up with 2. And the reason was because when we did the factoring, then one of those degree 2 polynomials that we ended up with just didn't factor any further. Or one of them did, but one of them didn't. So we got 2 solutions instead of 4. All right, so I think that just about covers every possibility that could come up except for the word problems. And the word problems in this section are actually kind of challenging. So the things that you need to know, because I will say this, they tend to revolve around triangles and rectangles. So like area of a rectangle, perimeter of a rectangle, area of a triangle, maybe the Pythagorean theorem. Those are things that are going to help here. And I like to draw stuff. So if you're kind of into visual learning type of things, then maybe you like to draw stuff too. But with number 9, that's the first thing I would be thinking. I'm like, okay, it's a triangle. I got to draw a triangle. But the height is 6 feet less than 3 times the base. So I guess that needs to be kind of a tallish triangle. Right, like a tall one rather than like a squat one, I suppose. And then, let's see, I'm just going to make the height a different color so it's easier to see. So maybe like that. And you'd have a right angle in here with the base, right? And then it says that, and I'll do this, I'll label these in a different color actually. The height is 6 feet less than 3 times the base. So I'm going to say where if the base is x, then the height would have to be, so 6 feet less than 3 times the base. Well, 3 times the base now would be 3 times x. And 6 feet less than that, so that's 3x minus 6. So I guess in the picture, that red line right there would be 3x minus 6. And then the other thing we need is the area of a triangle, right? So area would be 1/2 times the base times, and I should be using dots, not x's, because I'm using x as a variable. So 1/2 times base times height, right? But then here, that would mean that the area would be 1/2 times x times 3x minus 6. Right? But the other thing we know from up here, area is 72 square feet. So A is 72. All right, well then that would mean that we could say that these have to be equal to each other. Right, so we'd have that 1/2 x times 3x minus 6, is equal to 72. First things first, that has a fraction in it. We can get rid of it, right? We can clear that fraction, multiply both sides by 2. So 2 times 1/2 x times 3x minus 6 equals 2 times 72. But then the 2 times 1/2, those are going to cancel out. We're going to end up with x times 3x minus 6 equals 144, right? 2 times 72. You distribute the x here and you get 3x squared minus 6x equals 144. And then if you subtract 144 from each side, you get 3x squared minus 6x minus 144 equals 0. All right, but then actually, because it looks like we're going to have a trinomial where we have a leading coefficient that's not 1, but 3, 6, and 144 are all divisible by 3. So we can factor the 3 out. Outstanding. Because then we're going to be left with x squared minus 2x minus 48. And now, if we use the zero product property, then the trinomial's got to be 0. So x squared minus 2x minus 48 equals 0. But now look, we got a leading coefficient of 1. Yes, those are the best, right? Because then we can say, all right, we need a pair of factors of negative 48 to add up to negative 2. Sounds like that would be negative 8 and positive 6. All right, well then you could use the zero product property again and say x minus 8 equals 0 or x plus 6 equals 0. So then here you'd have x equals 8, and that is an answer. Here you get x equals negative 6. That is not an answer. So this one doesn't work. And why does that not work? Because this is a word problem, and these are lengths, right? Like the base and the height, like those are lengths. So it's saying you have a base that's negative 6 feet long. That's not really a defined expression, right? What's a negative length? So that one we can't use. So the reason we're throwing that one away is that we can't have a negative length. So you got to be careful with the word problems, right? If it was just here's an equation, solve this, then negatives are fine. But here, because it's something that's a length, you can't have it. So what's our solution going to be? Well, I think I have enough space down here to squeeze this in. So the solution, I wanted that to be blue. What happened? All right, now it's blue. All right, so the solution. So the base is just x, which is 8 feet. And then the height is 3x minus 6. And if you sub in, that ends up being 18, since 3 times 8 is 24, then minus 6. So it ends up being 18 feet when you sub in. So that's the answer, right? And I guess you could double check it. The area is going to work, because 1/2 of 18 is 9, and then 9 times 8 is 72. That worked out. So looks like we're good. All right, so that's one where the biggest thing, I think, is just remembering the area formula for a triangle, right? Like that's the thing that gets everything here to run, right? That makes everything work. That, and then make sure you throw out the negative at the end because it's a length. All right, number 10, where it says a farmer has 220 feet of fencing and wants to enclose a rectangular plot of land bordering a river. And if the farmer does not fence along the river, what are the length and width of the plot of the land if the enclosed area is 3,600 square feet? Okay, first of all, I would draw it. That's a good watercolor. So there's my river. And then, let's see, I need fencing, brown, right? If it's made out of wood, that's the color it would be. So So there's our rectangle, and we're fencing in this right here. So the enclosed area, which would be this, is 3,600 square feet, right? And then here, I guess you'd call that the width, same width down here, and then maybe that's the length, right? Because then for the area of a rectangle, it's length times width, and we're going to need that. So let's see here. What we're going to need to do is, so we know that there are 220 feet of fencing. But we're only using the three sides, right? There's no fencing along the river. So it's W plus L plus W that would have to add up to the 220. So that would mean that 2W plus L, to clean that up a little bit, instead of saying W plus W, that would have to be equal to 220. So that's part of it. And then the other thing that we know is that the area is 3,600, but also for a rectangle, area is length times width. But then though the 3,600 and the length times width would have to be equal to each other, because those are both the area of the rectangle. So length times width would have to be 3,600. Okay, so how do we solve this? Because we have two equations right now that both have two unknowns in them. So what we're going to do, and I guess I can put this maybe in red, is we're going to solve one equation for one variable, then sub into the other equation. And the easiest one to solve for one variable is the first one, to solve for L, right? Because the L has a coefficient of 1 already. Just subtract 2W from both sides, right? And we're good to go. And that's exactly what we're going to do. So since 2W plus L is 220, that would mean that L is 220 minus 2W, right? So all I did was get the L by itself, subtract 2W from both sides. But then if we sub into the other equation, so right now, I guess to start off with, we've got that L times W is 3,600, but then we're going to sub in and say that 220 minus 2W times W equals 3,600, right? So there's that big substitution step. We said if this is what L is, then we're going to sub in right there. And then we can multiply the W through, and we'd have 220W minus 2W squared equals 3,600. And if we're solving a quadratic equation, we want to get a 0 on one side. So if you subtract 3,600 from both sides, and I'm also going to write these terms on the left right now in the opposite order, so we end up with something in standard form. So minus 2W squared plus 220W minus 3,600 equals 0. And then this has a common factor, this thing on the left, because all these coefficients are even. So I can factor out a negative 2. And if I do that, I'm left with W squared minus 110 plus 1,800 equals 0. And then zero product property, the negative 2 is not going to be 0, so it must be the W squared minus 110 W plus 1,800. And we're going to need a pair of factors of 1,800 that add up to negative 110. And that sounds tough because 1,800 is a big number. But think of like what you would have if maybe you didn't have that many zeros. Like, what if instead of 1,800 you had 18? And if you kind of base it on that, I think you'll end up in the right place. Because then you could say, like, well, what if we tried like I don't know, negative 30 and negative 60. And you go, well, that doesn't quite work because that adds up to negative 90. Okay, how about negative 90 and negative 20, right? Because negative 9 times negative 2 would give us 18. And that actually does work. So W minus 90 times W minus 20 is going to do it. So it would be just like trying to find a pair of factors of 18 that add up to negative 11, except that now there are extra zeros. So instead of negative 9 and negative 2, we have negative 90 and negative 20. And if you use the zero product property, I think you can see it right here what's going to happen. We're going to have two different widths that work. So W minus 90 equals 0 or W minus 20 equals 0. So here W is 90, but if W is 90, then that would force the length to be 40. So just from subbing in, like if you use that L is 220 minus 2W, it would be 220 minus 180, which is 40. The other option is if W is 20, then the length would have to be 180, because then 220 minus 40, that's 180, right? And in both cases, you can check the multiplication. They're both going to work out to 3,600. So there are two separate solutions sets that are going to work here, which every once in a while that will come up. I don't think you can get that if there are some other adjustments here, but it's because it's the one where you only need to use the 3. Right? Since there are only 3 sides that you have to use the fencing on, there are a couple of different ways to end up with the correct area. Right? One is 90 by 40, the other one's 20 by 180. And I didn't put the units in there. I guess they would be feet, but I think I was just subconsciously thinking, I'm going to run out of room. I should make things as small as possible. But make sure you give yourself some time to do these word problems at the end. I think there are only 3 of them, but they are kind of challenging, and you do have to kind of remember those things about rectangles and triangles, like the area formulas and the perimeter of a rectangle and the Pythagorean theorem and that stuff. But that should cover just about everything that would show up in 4.8.